Are LLMs intelligent? Can they create something new? What are their limitations? And do prompts matter? These are a few things that I want to discuss in this video, and I don't believe I will get to the bottom of all these issues, but I think these are important questions to ask. So this is what we'll do today. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a deep dive into a few core questions related to large language models, or Gen AI, or what people call today artificial intelligence. So let's look at the first question. Are large language models actually intelligent? This is a very difficult question to answer, and the problem is that we don't really know how to define intelligence. There are various definitions, and some of them have worked for a while, but then they didn't work anymore. So basically, you could think about intelligence in two ways. I'm going to simplify this a lot. On one hand, you can look at functional aspects. Things like, in the case of people, what is their neural speed, how fast, how many connections are between neurons in the brain, and so on. And that would be similar for us programmers to things like CPU speed, memory capacity, cache levels, and so on. The functional aspects of computer, or in the case of a brain, the functional aspects of a brain. How fast things are triggering, how many connections are there, and so on. The issue with this is that it's very hard to monitor a brain, right? And it's very difficult to figure out what is going on there. And I think this is a thing that's shared with artificial intelligence. Although a very interesting thing with large language models is that you can kind of take nodes, identify a few of them, and then figure out what nodes do a certain thing and try to replace them with something else. I've seen some studies where they replaced certain words. So they realized that certain nodes in the neural network correspond to specific words or notions, like, let's say, the city of New York. And they replaced New York with Chicago, and they saw Chicago appearing in various places instead of New York. Very simplified example, once again. So it's easier in a way to do a kind of reverse engineering on neural networks than it is to do it in case of a brain, where you cannot just pick a neuron and kind of replace its function and see what it does. It's not possible and it's not ethical. So it's obviously not the same thing. So the second type of definition is behavioral, which is kind of a black box approach. We give the human or the large language model a test, and we see what are the results. And based on those results, we assess intelligence. But the problem with this is that we figured out, not we, but neural scientists figured out that there are multiple components. So generally speaking, there's growing recognition that intelligence involves multiple components working together. There's cognitive abilities like reasoning, memory, processing speed, adaptive behavior, which is a practical problem solving in real world context, and learning capacity, which is acquiring new knowledge and skills efficiently. So the problem here is we don't really understand human intelligence. So how can we claim to understand non-human intelligence? It's completely different. And so there are a few questions here that I'm wondering about. First is, people say that large language models are basically glorified autocomplete. And that is correct, but the thing is, autocomplete, in the case of large language model, it works on different levels and it works on a statistical basis. So on different levels, it means it looks at the next word, at the next group of words, at the next sentence, at the next phrase. And it does this based on a statistic pattern matching. So it's more likely for certain things to follow other things, and that's what it looks like. Now, the interesting thing, if we look at the behavioral aspects, I would argue that large language, on black box style responses, I would argue that large language models are much smarter than we would have expected. I mean, the only thing that they did was they took a lot of data, basically the whole internet, right? Mixed it into a vector database that shows these statistics, kind of splits into pieces and creates these statistical connections. But then the result is that we get answers that sound often logical, that sound often intelligent, even though there's no notion of logic, there's no notion of mathematics, there's no notion of computation in a large language model. There's no notion of what a thing means. There's just a node somewhere that is connected to another node based on weights that are derived from statistical analysis. But then this raises an interesting problem. Is language more important than we thought for intelligence? We often associate intelligence with things like cognitive abilities, what we talked about here, adaptive behavior, learning capacity. But could language be fundamental to this whole thing, to this whole construction of intelligence? And if you look at the evolution of human species, I think that there might be an argument for this, because language was always some part of this behavior, some part of the brain, right? And then we have this interesting thing that, Chomsky's universal grammar. What Noam Chomsky showed, it was a theory, a hypothesis, but I think it's more and more probable right now, is that it's not that we start with zero knowledge of language when we are babies. We are born with the structures that allow us to learn any language, which is fascinating because it means that the functional structure are somehow there. And it looks to me as if the large language models take takes the language and kind of reverse engineers those functional structures in a way or other. Now, of course, what's missing is probably other functional parts, the parts that are related to logic, the parts that allow you to do reasoning or mathematical reasoning or logical reasoning, critical thinking maybe. But a lot of it is language. And I've seen that some people were saying that one argument against large language models being intelligent is that we perceive language as intelligence. But maybe it's the other way around. Maybe language is the foundation of intelligence, and we build on top of that in our brains. So the question I'm pondering is, could intelligence actually be a mix of pattern matching and emergent properties? And what I mean by that is, okay, large language models are doing pattern matching in a sense, right? This is what the brain is doing as well. Our brains are very good pattern matching machines, and we know that because of the logical fallacies. Logical fallacies are basically pattern matching gone awry. It's gone overboard. It's going too far, right? So pattern matching is a fundamental part of this. And in a way, the large language models are doing a form of pattern matching because it's based on those statistical models. So they see a question, they see a prompt, and it's likely that certain things follow after that prompt. And so they generate that answer. And once they start, a sentence, then other things follow, and so on. So this is a very, very intriguing question for me. And I think it's a bit unfair to say large language models are not intelligent at all because they don't do logical reasoning, they don't have memory, they don't have that. I think the interesting question is, could language be in the center actually? And the things that are derived, that are built on top, that are combined to our logical thinking and so on. Because in that case, you could take a large language model. Well, in theory, we don't know how, as far as I know. But imagine you take a large language model, combine it with some modules that do logical thinking, and somehow make this work. Of course, the big problem is how to make this work. But then you will get reasoning, memory, and language. And perhaps with this combination, you get intelligence. But honestly, I wouldn't expect that intelligence to be higher than human. I would expect it to be very similar to human intelligence. But that's okay. That's just a supposition. That's just a claim that I'm making. So this is already very interesting, but now we can move to the next one, which is, can large language models actually create something new? Are LLMs creative? And the general answer to this is, people who say that large language models cannot create something new, they say they lack the experience. They don't live through experiences, they don't go through what people are going. They don't have the insights that people have in a specific topic. So if you take a creator, like a painter, like a musician, like a writer, they go through certain experiences, and based on those, they create something that is uniquely theirs. And I think there's a valid argument here, but let me ask you a different question, and then I'll come back to the initial argument. And the question is, where does creativity come from? And I think, well, I really hope that part of it is this insight, this experience. It's something that you have to go through. It's something that we don't quite know how to define. But I would argue that part of creativity is combining things that have not been combined until then, or combining things in new ways. Okay? And I noticed that in order to be more creative, at least for me, one thing that's really useful is to be submitted, to be exposed. It's a better word, to be exposed to randomness, basically. So I am more creative when I am walking around looking at random things. I'm more creative when one thing, by the way, that I like doing with Claude, the AI assistant, is to ask him, give me 5 random things from the internet, and ignore things like politics and sport, because those are not very interesting, but give me 5 random things. And then I look at those, and those are the ones that spark creativity. Is it possible that creativity is just a complex anagram engine that happens on multiple levels? And allow me to do a little bit of a detour here. One of my favorite books is called Foucault's Pendulum, and it was written by Umberto Eco. And Umberto Eco is a genius author. Well, was, because he died. But he was a genius author because he was also a genius in the science of semiotics, which basically talks about how we transform symbols into meaning. What is the connection between, let's say, a few smidges on a paper and words, and something that you actually understand, that you can visualize in your mind? And all of his books have something connected to semiotics, but I think Foucault's Pendulum is one of the greatest books ever written. The reason for that is it happens actually on multiple planes, and it's very difficult to grasp it. I had to read it about 3 times to figure that out. But another thing, one of the core themes in the book is anagrams. The book starts with a group of people playing around with a computer and doing anagrams, but doing anagrams of particular sacred words from sacred traditions, and discussing how the anagrams of sacred words influence the world they live in. And then they actually start doing anagrams of ideas. They start grouping ideas and compiling them and so on. And they end up creating a conspiracy theory, kind of Uber conspiracy theory that is not actually true. Of course, they just mixed and matched things from various other conspiracy theories, and they get into a very believable conspiracy theory that is adopted by a secret society. And at the same time, they are discussing about the biology of anagrams and how, for example, cancer is about anagrams in genes, in the genome, and so on. So it's a very, very interesting book about anagrams. And basically what I learned from it is that by doing anagrams, by combining ideas in various ways, you can create new meaning, right? And if you are watching the internet on any specific thing, you know that. Whenever there's a very followed TV series, like how it was with Game of Thrones, There were people throwing out all possible theories about the ending of Game of Thrones. And eventually somebody, through this process of combination, they ended up with one theory that was actually the one that I think was in the final episode. But this is a very interesting thing because, okay, large language models are autocomplete on steroids. They are a statistical engine, so they go and combine things. Okay? What are the chances, and can you actually make them travel less statistically relevant things? Because by statistically relevant, what we mean is that they got the whole internet and they saw that things fit together. Okay? But if you could give them a specific prompt that allows them to travel through lower ways, through lower statistical paths, then that might create new things. Now, is this equal with people's creativity, with human creativity? My personal hope is that it's not. I hope that creativity is more than that, that you have to put something specific to you in the work, and that something specific is not something that is visible to a large language model because it's not statistically, is not included in the statistics, right? Because it's inside you, it's something that you have. It's very likely that we have something particular to each of us that allows us to create things that only us can create. On the other hand, saying that large language models can never create something new, I don't think that's completely true. I think they can mix and match things that already exist. And when you have all the internet, basically, mixing and matching things at different levels will create something new eventually. Now, will that be good? I'm not sure. That's a completely different thing. But creating something new, I think it's possible with large language models. All right, now let's talk about the next one, which is what are the limitations of large language models? We now know from a study published by Apple recently that models collapse after high enough complexity. So what they did was they tried to give them logical problems, things like Towers of Hanoi, and they increased the number of pieces, and once the number of pieces got high enough, they couldn't do anything with it anymore. Now, this is still a bit difficult to say, okay, this is definite proof, but I've definitely noticed that large language models, the wider the context, the less good information they give you. And they are very useful for very specific things that you can verify quickly. Code is one of them, because code, okay, we generate some code, we can test it, we can see it works. And others are texts, texts that in a specific domain where you can verify that they are correct. There are a number of these things that we can do. But once you go to general questions, general domains, it's much harder. And my feeling is that if you try to give them complex problems, they will just not work. But I'm curious what your experiences are here, because I'm still experimenting in this area. I know another topic where I've seen large language models fails. So I tried prompting them for domain modeling. That was an interesting experience. I gave them, this is the description of a problem. Now, okay, it was a relatively simple problem. Give me a domain model for that. It gave me a domain model that was so generic. It was not fit for purpose. So it wasn't something that, it was not usable, basically. I know other people experimented with large code bases. So they gave large code bases, started asking questions, didn't get very good answers. Or the changes that the assistants made in large code bases, they were not fit once again, and they had to redo them and so on. But then this is an interesting question, because if context and the complexity of the context is a problem, the solution to using large language models in specific context is to reduce that. And you reduce the complexity by doing divide and conquer, right? By splitting larger things into smaller things. Now, this is a bit of a problem when you are dealing with complex adaptive systems, because then you have a lot of connections between various elements. But if you can split a larger context into a smaller one, they will probably tend to be more accurate. One example here would be, instead of giving them a large code base, you just work on a module. And if you have specific guidelines for the module, you include them and so on. So I'm curious, what are your experiences with the limits of large language models? Of course, we already know, and I mentioned a few. Reasoning, I don't expect them to be logical about things. They might generate a chain of reasoning, which is an interesting thing. And by the way, it was an emergent property. So it comes up out of the model under specific constraints. So the chain of reasoning is generated, but it's not precisely how it reasons, which is another thing. They are actually lying about how they reason. So reasoning, we don't know. Logical reasoning, memory is limited. We know that there's a limit in computation, right? They don't know how to do math properly. These are a few, but I'm curious if you tried anything else. What did you notice? What were things that were missing, that were not working as expected? And the last one, to which I'm not sure I have a good answer, is, do prompts actually matter? And by do prompts actually matter, what I mean is, there are all kinds of prompting strategies out there. And people are swearing, you really have to tell the assistant that, act as a marketing specialist. This is the context, and these are the limitations, and that's the question. And I'm really curious if these are imagined benefits or real benefits. And I don't know. I mean, the thing you could do, I imagine, in this scenario would be to look at the connections, look inside the model, and see which nodes are triggered, and see whether they go on a different path depending on the different prompts. I tend to like simpler things, and I use simple prompts most of the time, and I got quite good results. And then when I couldn't see a difference between, in the few occasions when I tried a simple prompt versus a more complex prompt for the same problem. So I don't know, do prompts actually matter? Do we have studies that prove that if you structure the prompt in a certain way, then you get a better answer, a more qualified, better expertise, more precise? I don't know. So what is your experience with prompts? That's another question that I would like to answer. All right, so these are a few questions that I wanted to talk about, and I think these are fundamental to large language models, and they also show kind of where I am with these tools. I don't see them as a replacement for people. I see them as tools that can help people be more effective when used properly. And this, when used properly, this is the big question mark right now. How do we use them properly? Where do they apply most effectively? And this is kind of what I'm trying to figure out. And I'm trying to figure this out in the context in which there's a lot of noise. You know, people are pushing for products, for startups, for financing, so there are a lot of money involved. Of course, there is a lot of noise around this, and a lot of, it's probably a bubble as well. So we'll see. But I'm always open to pragmatically using tools that help me. So I'm going to look at how these tools help me. And as I said in the video last week, I think I still believe that more and more companies will ask for engineers, for software developers to know these tools. I'm curious on how to use them effectively. And I plan to do a series of experiments with large language models in various contexts. And if you have any ideas for where we might try them, let me know. Some ideas are for domain modeling, where I don't think it will work that well, but yeah, let's try it. Why not? But then for things like, let's say, once you have a specification for your microservices written in OpenAPI specification, then you can use that to kind of generate microservices. There is a study about that I've read, and it was quite interesting. They hit some limitations, but the question is, does it help or does it just not work? And of course, I'm far from doing scientific experiments. I will just try out things and see what happens, and then maybe we'll get to a collective wisdom around these topics. That's what I would like to see. All right, that's it from me today. What do you think about all this? Let me know in the comments. Leave us a like, give us a share. Subscribe to the channel because there's more of this coming. Or if you want me to talk about other topics than large language models, that's fine as well, but just let me know. It's great to hear from you. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.